Thank you for tuning in for the University of Pittsburgh's Human-Powered Vehicle Innovation Report. My name is Gerard Tessier, and I'm speaking on behalf of Hunter Gaspin, Atharva Deshpande, Hussein Aldawood, and Rowan Walker, along with the whole HPVC team at Pitt. Last year's Human-Powered Vehicle placed fairly well at the regional competition. With high hopes of improving Pitt's performance in 2018, we began looking for new and innovative ways to get the edge. We decided to use a power meter to find each rider's optimum seating placement. In order for the system to be useful, it had to be accurate, find the force applied by the user, and be wireless. After discovering that purchasing a power meter was out of the club's budget, we decided to create one. This required 3 new tasks: fabricating the power meter and test rig, as well as figuring out the software. This led to many new questions, as well as many answers. The next step was machining the crank arm to provide a flat surface to adhere the straight gauges to. After the gauges were mounted, they were calibrated using known masses. The results were graphed, and a relationship between the torque and the voltage read was established. There are 2 parallel electronic systems that communicate through Arduino microcontrollers with XP wireless communicators. The first half of the system contains the strain gauge and Hall effect sensor, while the second half outputs the real-time power to an LCD screen. Both the force transducer and the speed transducer were able to meet the requirements set out by the group. In the beginning of the project, the expected budget was well over $500. Partway through, though, it was discovered that the budget was actually around $200, presenting new challenges for the club. A test rig was created to compare the power output of a wide variety of seating arrangements. The rig was designed to have significant adjustability with 3 degrees of freedom. As budget was now a larger consideration in the design of the rig, parts were salvaged from last year's model, team members' spare bike parts, and when necessary, low-cost stock materials were purchased. The geometry of the test rig is based off of the average length of someone's legs as well as the average seat tube angle from upright as well as recumbent bicycles. Supporting and structural analysis was then completed. In parallel to these calculations, the frame started to be fabricated. The adjustable parts were fastened while the permanent parts were welded. Once supporting analysis was completed, it was determined that the seat and pedals required additional structural supports, seen here. The test rig also successfully met all of the requirements set by the group. The final demonstration can now be seen on the screen. On the left is Atharva using the test rig, while on the right is the LCD display showing the power generated in real time. Some future improvements that we see for the system are using more compact meters on each crank arm, using a full Wheatstone bridge, and including sliding rails on the test rig. Everyone involved in the project took away different lessons from partaking in this innovative endeavor. Special thanks to everyone that helped us with this project. Thanks for watching, and this is Pitt HPVC signing off.